All right, so if we look at STAAR review number 1, the first topic we're going to cover is A2D, and it is ordering a set of real numbers. So we're going to order a set of real numbers, meaning putting them in order from least to greatest, greatest to least. Before we get started with jumping right into solving the problems, let's talk about strategies. You can look at this first problem. If you were to solve it, what would be your strategies? What would you do first? Convert them to decimals. I love that. So maybe make yourself a note. We want to convert to decimals. Why do we want to convert them to decimals? So that way they're all in the same format. Really, you can make them all percents, all fractions, or all decimals, but decimals is the easiest way to order. What else would you do? Oh, I like that. Original form in the answer. Original form in final answer. Another thing that I would do is I would make my brain note. Remember when we talked about writing like L to G or G to L to kind of set it out with what order you're doing it in? Because sometimes those word problems get real wordy, but if you make yourself a little note about what you're doing, it helps remember what order. Because it would be awful to do all the work and put them in the opposite order that they asked for. All right, so let's look at this problem. Put the list of numbers in order from least to greatest. So first I'm going to make my brain note really big so I know I'm starting with least, going to greatest. Next, I need to put all of these into decimals. Well, if I look at my first one, it already is a decimal, right? So I'm just going to rewrite it, negative 8.1. So if I'm writing, you should be writing. Number 2 is already a decimal, 8.05, so I'm going to rewrite it. And you may ask, well, Miss Marling, why are we having to rewrite it? Well, the strategy that we use, remember, I'm going to put all my decimals on the same row, so I don't, if I didn't write this one, I may forget to go back up top and pull that decimal down. And then 81%, how do I write that as a decimal? All right, what was it? 0.81. What if I didn't know that? How could I use my calculator to help me? Why would you divide by 100? Because percents are out of 100. So 81 divided by 100. You could also, couldn't I just put 81% in my calculator? I sure could. 81. And remember, the percent key is right here next to the G. And then I scroll over, get my percent. Enter. That gave me the 81 over 100. Control Enter gives you your decimal, 0.81. So if you didn't know that, we could use our calculator. All right, the last one is negative 33 over 4. How would I put that in my calculator? Negative 33 divided by 4. Or I could use the fraction button. What did you get as your decimal? You do it. What did you get as your decimal?
Negative 8.25.
You got it. Negative 8.25. Now, we're looking for least to greatest. Well, I have negative numbers and positive numbers. If I'm wanting the smallest, what's going to come first, negatives or positives? Negatives. So right now, we're looking between these two numbers. And what do we know about negatives? The bigger the negative, the smaller the value. Everybody say it. The bigger the negative, the smaller the value. So out of these two, because I want the least, which one has the smallest value? Negative 8.25 or 33 over 4. So that is in first place. So now that means negative 8.1 is in second place. Who comes in third place? 81%, because that's really 0.81. And then 8.05 is in fourth place. But am I done? No, I need to write my answers with the original form. So what am I going to write first? Negative 33 over 4. Negative 8.1. 3 is 81%. And last place, fourth, is 8.05. There is your final answer. All right, let's look at the next one. Right here. Each student calculated the diagonal of a rectangular garden differently. Order the answers from greatest to least. So what brain note am I going to put to help me remember? G to L, greatest to least. All right, we need to put these in decimal format. The first one's already a decimal, okay? 8.49. 8.5, I should know that one. 8.5 or 8.50. Now, what does this say? How would I put this in my calculator, this third one? Right, 6 times the square root of 2. So do that on your calculator, 6 times the square root of 2. And what did you get? Just read me the first two decimal places. 48. Don't round it. We're just reading real place values. Yep. And then the last one, square root of 73. 8.54. Now we're looking for the greatest. So whose measurement was the greatest? Darren. Got it. 8.54. Who's next? Bibby. Very good. And number 3? Alex. And number 4? Flavion is 4. But we want to make our final answer. So what am I going to put with my final answer? What's going to come first? Square root of 73. It said order the answers. It didn't say order the people. Sometimes they will say order the people, and your answer would be like Darren and then whoever. But this one did say order the answers. So square root of 73, then what? 8.5. And then in third place, 8.49. And last place, 6 square root 2. 6 times the square root of 2. Final answer. Yes. Nope. I'm teaching. All right. Let's look at this one. The chart shows the portion of a project that each student completed. Put the numbers in order from least to greatest. Least to greatest. Make the brain note. Make them all into decimals. Oh. Is what? Okay. 0.77, yeah. What is it? The next one? 0.76, all right. Now do the next one. 0.76. Oh, wait a minute. I have two that are exactly the same. Are they exactly the same? They're not. This one was 0.76, right? So I need to take it out to a third place. That's a 0. What is 13 over 17 out 3 places? 764. And then that means the first one, if I go back up and take it out to 3 places, it's 0.77 what? 7. So notice, if I would have only taken this out to 2 decimal places, I wouldn't be able to tell who's bigger and smaller. So we had to carry it out to a third decimal place. And then this one is already a decimal. All right, least to greatest, who's coming in first? Xavier, 760 is the smallest. Then who's next? Yanirus. And third? Sophia. And Wina for fourth. Put your final answers in order. So you have 76%. 13 over 17, 0.768, and 7/9. Now be honest, how many of you probably would have put 7/9 first if you did not change it to decimals? Yeah, because it looks like a small fraction. Because it's a fraction, so your brain thinks small. They're both 1 digit, so your brain thinks small. But remember, all of these numbers are equally small. That's why we put them in decimals. All right, on the last one, put the area of these circles in order from least to greatest. Circle B is 2 squared times, that's a pi symbol. They just chose a poor font, but that's a pi symbol. So let's get these all to decimals first. A is already a decimal. We're good to go. B, what is B as a decimal? 2 squared times pi. Will you wake him up next to you, please? Thank you. What was it?
12.56.
Yep, 12.56. If that's out 2 places, if I were to take this one out 2 places, what would I add? 0. All right, do the last one. What did you get that as a decimal? What'd you get?
2.39.
Okay. Or what'd you get? All right. So I have 2 different answers. How many of you got 2.29? How many of you got 3.24? Couple people? Okay. The correct answer is 2.29. For those that got 3.24, let me show you what you did and how to fix it. Okay? Let me get my calculator on. Let me clear it. Okay, for those of you that got 3.24, look up here. I know you did square root 21, and then you hit divided by 2. But watch what happens. Do you see how the square root symbol is real big? Is your square root symbol real big on your calculator? Is it real big here on our paper? No, so let me show you how to fix it. Square root 21. Do you remember how when we're working in fractions you have to arrow over to get out of the fraction? It's the same thing. I need to arrow over to get out of that square root symbol. Now when I divide by 2 and hit enter, you see how it's a small square root. So that's the difference. Okay, so 2.29. So if we put these in order from least to greatest, who's in first place? C is in first place. Who's in second place? Third place? And let's rewrite them. Square root 21 over 2. 2 squared pi, and then 12.6, final answer. So that's our review and refresh on ordering real numbers. Any last minute questions? All right, let's flip it over. Let's see what we're going to learn about now. Oh my goodness. No, I'm teaching. It's a type of transformation. Specifically right here, we're going to talk about dilations. What happens in a dilation? What does it mean? Right, it's either shrinking, getting smaller, or it's enlarging, getting bigger. All right. So stuff gets smaller, and stuff gets bigger. So we know that. The answers will be in the form of xy with that arrow going to some number times x, that same number times y. Remember, dilations is the only one that uses multiplication. Does anybody remember this letter A? Does anybody remember what that's called? We use it by finding new over old. It is called your scale factor. So A is your scale factor. So when you have an ordered pair, if I take that ordered pair and I multiply the x coordinate by my scale factor, I get my new x coordinate. If I take my y coordinate by my same scale factor, I get the new y coordinate. Okay? So let's look at this first one. Circle 1 was dilated with the with the origin as the center of dilation to create circle 2. Which rule represents the dilation? Well, first of all, I need to figure out which one was the old, the original, and which one is the new one. But I'm going to label it on my graph. So which one is the old one, circle 1 or circle 2? Circle 1, so I'm going to label this as my old circle. And circle 2, I'm going to label as my new circle. So we know we're starting small and we're getting bigger. Well, what do I know about a scale factor if something gets bigger? Yes, say that loud. Right, so if something gets bigger, my scale factor has to be greater than 1. So if something gets smaller, what do you think the scale factor has to be? Less than 1. My scale factor would be less than 1. So because this one's getting bigger, when we find our scale factor, it should be larger than 1. All right, this doesn't have any flat sides, so we're going to have to use ordered pairs. So I am going to pick 2 pretty points that correspond to each other that are ordered pairs. I'm going to pick these 2. Could I have picked these 2 that are pretty points? Yes. Could I have picked these 2? Yes. But I'm going to pick these 2. Well, on the old circle, what is that ordered pair? 0, 2. On the y-axis, on the big circle, that ordered pair on the y-axis, 0, 5. So I need to look at what did I multiply the old coordinates by to get the new coordinates? Well, 0 could be times any number to get 0, right? So I need to think about what am I doing to 2 to get to the 5. And we're going to use that by finding our scale factor right here. New over original or old. So scale factor equals new over old. So scale factor, well, what is my new y coordinate is 5, right? What is the old y coordinate? 2. So 5 over 2. What does that simplify to as a decimal? 5 over 2 is a decimal, everybody. You have a calculator. If you're not answering out loud, you should be punching it in your calculator. All right, you should get 2.5. So thinking in decimals, it's a little bit easier for our brains to compute. If I take my old x value, 0, times 2.5, does that give me my new my new x value? 0 times 2.5 is 0. What about the y value? 2 times 2.5, does that give me 5? Yes. So that is my scale factor. So then to write the rule, we always start out with xy. We're dilating, and I have to take my scale factor times x, scale factor times y. So 2.5x, 2.5y. So that would be your rule. I could also write my rule as my fraction. That would be just as correct. I could say 5/2 x, 5/2 y, because that's a fraction greater than 1. So either one of those answers would be correct. All right, in this one is just going the opposite way. Circle 1 is the old, circle 2 is the new. So if we're getting smaller, what do I know about the scale factor? It should be less than 1, and it would be a half. But we're not going to have time to calculate that one together today. But again, if you wanted to, pick your pretty points and do new over old. All right, let's go down here to the bottom, because these are the ones that we like. These are the ones that have shapes, have figures. When you have figures that have straight lines, I think it's a lot easier. Could I pick 2 ordered pairs that correspond? Absolutely. I could pick an ordered pair that would be like right here and right here. Those are 2 corresponding ordered pairs. But because I have side measurements, I could also use the side dimensions to find out. But first we need to label which one is the old and which one is the new. You might have to read the word problem to figure it out. The small one is the new because it says up here the large arrow is dilated. So the large is the old, the small is the new. Well, now what's really cool is I can use a side measurement. So I'm going to use 2 corresponding sides. So I'm going to use that part of the big arrow, and I'm going to use this part of the small arrow. Do you see how they're corresponding sides? All right, so how big is the old one? 4. How big is the new one? 2. All right, let's find our scale factor. Scale factor is what? How do we find scale factor? New over old. So my scale factor, my new dimension is 2. My old dimension is 4. What does that simplify to? 1/2. And if I wanted it as a decimal, 0.5. So I could write my rule as a fraction. xy dilates to 1/2 x, 1/2 times the y coordinate. Or I could write it as a decimal. You never know which way your answer choices are going to be. So the equivalent decimal would be 0.5x, 0.5y. Now let me ask you this. If I didn't want to use these sides, could I have used this part of the big and this part of the little? Yeah, because this would have been 2 and this would have been 1, which new over old would have been 1/2. So you could use any corresponding sides. Would I use the diagonal? No, because you can't accurately count a diagonal. So I would either use a horizontal or a vertical side. Any questions on that one? All right, let's look at the last one. Quadrilateral ABCD was dilated with the origin at the center of the dilation to create quadrilateral A prime, B prime, C prime, D prime. Which rule represents the dilation? Well, first of all, how do I know which one is the old and which one is the new? What? It shows the prime right here, this little apostrophe. That little apostrophe is called prime. So does that apostrophe make that shape the old or the new? That makes the new. The prime is always the new. The old would be the one without prime. All right, so let's do some side measurements. I'll use the bottom since I didn't write down here. So how big is the new segment? 4. How big is the old one? 2. So then scale factor. First of all, we know we're getting bigger, right? So what do we know my scale factor has to be? It has to be greater than 1. So new over old. What's going to be my fraction? New over old. What is it? 4 over 2. What does that simplify to? 4 divided by 2 is 2. So 2 would be my scale factor. So then my rule, xy dilates to 2x, 2 times y. So I could take any ordered pair of the original, multiply each of those dimensions by 2, and that gets me the new ordered pair. Any questions? Okay, your job. In Schoology, there are 2 post-assessments. One post-assessment, STAAR post-assessment 1A and 1B. The first one is over our ordering integer, or real numbers. The second one is over dilations. They are both a daily grade. You get 1 attempt. If you don't finish, that will be your homework. If the bell rings in the middle of the assessment, you can resume it when you get home.